Alright guys, let's look at the next subtopic on differentiation. We have a chain rule. Okay, in chain rule, what happened is that we encounter with a function that is within another function like this. So as you can see here, function gx is within fx. So we use chain rule as a structured way to conduct differentiation. Okay, so we can also use chain rule to solve this kind of function where you have set, right? So let's see. The formula is dy over dx is equal to dy over du times du over dx. So this is sort of kind of the expansion of this, right? You see here, if you cancel out du, you'll get dx, dy over dx. So for chain rule, in order for us to solve for the dy dx, right, we need to first determine dy over du and du over dx. As we have discussed before, when we say the differentiation of dy over dx, you can imagine that it is the derivative of y in terms of x, right? So how do we look at this one? Dy over du, meaning that you'll need to have a function that is y equal to, in terms of u, and du over dx, meaning that you'll need to have a function that is u equal to x, right? So basically we need to recreate this function based on our original given function later. So let's discuss this concept through exercise 4.8. Alright, so let's look at y equal to e sine to the power of sine x. Alright, as you can see here, we have a function inside another function. So this allows us to use chain rule to conduct the derivative. Okay, so the formula will be dy over dx equal to dy over du times du over dx. Okay, first of all, we'll need to find dy dx, we'll need to find dy over du and du over dx. And of course, dy over du can only be found when we have a function that is y equal to an equation in terms of u. Okay, currently we only have y equal to a function that is in terms of x. So we need to change this to make it in terms of u. So how are we going to do that? Right, the way to do that is by defining a function inside these functions, sine x here as u. Right, so we define u equal to sine x. It is that we want to remove x, make it u. So so we make sine x as u. So rewrite the function to y equal to eu. Now, as you can see, we have changed the functions of y in terms of u. So by using this, we can look for dy over du. So the properties of exponent, the derivative of eu will also equal to eu, right? So dy du equal to eu. So we have this one. So let's see how to find du dx. Remember that we have defined sine x as u before. So automatically we have a functions of u in terms of x. So we can use du over dx, right, to find the derivative of u equal to sine x. So du over dx is equal to cos x. So the next thing to do is to input everything inside this formula. So we have dy over dx equal to dy over du, which is EU, times with du over dx, which is cos x, will give us EU cos x, or if we try to substitute the u here, we'll know that u here is equal to sin x. So the final answer will be e sin x cos x. Right? So that is the first exercise. Now for the second one, okay, as you can see, we have a function that being powered. Right? There is no other function inside the function, but we can solve this equation by using a chain rule. Alternatively, we can also use the idea of power rule with a little bit of additional steps. Right? We're going to discuss that also. Okay, so let's try to solve this using chain rule first. Okay, so this is the function, and we try to solve this using chain rule. Okay, as usual, we need to redefine the functions here with y in terms of u and u in terms of x. So let's first look at this. We have currently y in terms of x. We need to change that into y in terms of u. So in other words, we'll need to change all of this that have x in their as their terms into u. In other words, we'll need to redefine all of this into u. So this is how we do it. We redefine all of the whole functions here as u. So u equal to x row 3 minus 4x plus cos x as u. Okay. So when we rewrite it again in terms of u, it will become y equal to u to the power of 3. Now that we have y in terms of u, we can differentiate y dy over du. Alright, so differentiate this using power rule. Right, so we have 3u to the power of 2. The next one is du over dx. Right, we have it here, u in terms of x. So in other words, we are going to differentiate u, this whole function here, to get du over dx. Okay, so just differentiate it as it is. We have power rule here. We also have constant, and we'll have trigonometric. So differentiate them accordingly, and you'll get this. The next thing to do is to input all of them in this formula. Alright, so we have dy over du, which is 3u squared, times with du over dx, which is this. Okay, so next we expand u, which is this. Right, so this is what we get. Right? We input the u, the function of u again. So this is what we get. So you can leave the answer like this, or you can also multiply this constant with this function to get this. Right, so sorry, let me move it. Okay, like this. So that is for this one. The next way to solve this kind of question is by using the idea of power rule with some additional step. Right, so that's how we do this. At first, right, do exactly what we need to do in power rule, which is bring the power in front. Right, you get 3 in front and subtract the power to 1, so it will become 2. And the next step, the additional step, will be to redifferentiate, right, again the function inside this bracket outside. So that will give you this. Alright, and this is the answer for this one. Alright, so that is the alternative way, right? Okay, so that is on a chain rule.